G'day guys, got the, hang on, shut the door here. Got the GPX6000 operating on the bench, and I've got the oscilloscope probe near the coil. I don't want to probe in the detector. It's as soon as I put the oscilloscope probe anywhere near the output, or on the output should I say, the detector wants to go nuts. At the moment I have the coil dumbed down with my copper cloth over it, but we can see the transmit waveform here. I'll leave it like so. There's one pulse is off screen at the moment, and that's the one on the left hand side. It's exactly the same as the one previous, the one that's already there. So it's actually previous to the one that's there. I'll just change the time base. And I've got this tripod in front of the oscilloscope, so it's a bit hard to work around, but if I do that, depends where it's triggering, of course, but you got a pulse here. Hope you can see where I'm pointing. That's a transmit pulse, that's a transmit pulse, and this little one here will join up there. That is just a, well, probably better to do this and explain it this way. That there's another one here, right? But if I zoom in too close and try and get them all, it's all squashed up, or it's all spread out and you can't see what's going on. It's got two pulses here. I've got the cursors on that at the moment, and it's saying that they're 63 microseconds long. So this is obviously for ground tracking or the deep gold pulses. Then we've got 1, 2, 3, 4, 5 medium-sized pulses. I haven't measured those yet. I haven't actually got onto it, but I'm suspecting they're probably around 35 microseconds long. Very much the same as what's in normal GPX detectors, the older version GPXs, not the 6000, of course. But 1, 2, 3, 4, 5 of those. And then there's very, very fine pulses here. And I suspect those are for very, very tiny gold. So you got a lot of mid-range there. You got a couple of big ones, very much like the older detectors. I think for memory, yeah, I think they might have been. This probably makes sense. For the older detectors, we had the 120, wasn't it? 120 microseconds long on the long pulse, and maybe there's two of them, and it's all worked out mathematically, so you can do your ground subtraction and the thing will balance. So if I can get in there, I don't know if I can. Yeah, I've sort of closed myself off from the workbench by putting the tripod in front of it. So how do I just get back a bit with that? Move that over here a bit. And I'll just get in there and I will see what I can do. Now I've got the coil dumbed down, like I said, with the copper mesh fabric. And if I move that, the detector will go off, start making horrible noises. The only way I could work out how to stop the noise here is if I actually unsoldered the speaker. There's no way of unplugging it. It's all soldered onto the mylar and goes into the detector. And that is then connected up to the head unit and that, so it won't function without it. So we'll have a look-see here. So we've got those big long ones there, which I'll go back there. You can see there's two big long ones. And we'll move up a little bit. I want to try and get as much as I can, and yeah, I probably have to push that again. Okay, down you go. We'll see how long these ones are. I think I got to bring them. I think I was meant to do the small one first, the way I've got it set up. Back here. Yeah, it's going off screen. There we go. Get on that one. There. And we'll bring this one over. Okay. Bouncing on the line. Well, that's interesting. 12 microseconds, 12.2. So we got 5 12.2 microsecond, or we'll call them 12s. And yeah, that's interesting because that's getting to an overall value of 60 microseconds if you add them all up. So it's a mathematical correlation between the large pulses and these 5 12s, and the other ones were 60 odd. Now let's see if we can, I'll have to adjust the delay here, and we'll get onto those small pulses. Make sure there is that actually looks a bit bigger, or is that my imagination? Hang on a second, let's have a look at that. That there, I grabbed the wrong one, of course. Okay, that's 1, 2, 3. They're actually different sizes. Oh, that's interesting. That is interesting. So that one's 12.2. Move the cursor, please. This thing does auto calibration every so often. It stops and goes click. Let's have a look at this one. It could be an optical illusion. No, they are the same because it wouldn't make sense. Let's just check. I think it's the grid was causing an optical illusion there or something. The way the waveform was set up on the grid. Oh, that's all the same. And this one here, this is the one that actually looked different. Oh, it is different. It is different. I'll bring that out. Get it on the line. Oh, there we go. 16 or 15.9255 microseconds. So if that's 16 and the other ones are 12, I wonder if these ones, the two little ones, are 2. I wonder if they're 2. That would make some mathematical sense. So what I'll do, I'll bring everything in. I want to get on those two little ones there. Okay. Bring the whole thing over. Very hard to see little arrows bouncing around there. I've changed the color scheme, like I said before, so that it might be easier to see. I don't know. Okay, got them on the line there. No, they're actually 4. So we got, that was me touching the coil connector. I told you it would go off. Damn it. Hang on. It's probably going to keep doing that now until I move this, please. No. Hang on. It's so touchy. Please, come on, calm down. Oh, dear me. I've set the bucket of noise off. Hang on. please. Yeah. If I move things around too much, I've got the volume as low as it'll go on this detector as well, so hang on a second. The only thing is I'll do things, I'll lose the signal. There we go. See if that shuts it up. Please. Oh, no. It doesn't want to shut up. Okay, I'll make a complete short around it. There you go. That I've shorted the coil out with wrapping the coil right round so it's a complete continuous loop. Yeah, don't really want to do that, but you can see that all the flybacks there are probably stretched out. You can check that in a minute anyway. But what we'll do, I'll bring this across. And I've gone too far, I should have touched the other one. Yeah. So according to this, there we go. I could get that more accurate. That's 5.87, so around about 5 or so. So that's your mathematics on that stuff there. I don't know if it actually might have an offset for some reason, but I've never seen that in any other detector, that waveform. I'll get rid of the delay, bring it back. So if you want to see it all in one hit, that's what it looks like. Basically, all bunched up. So there's 2, 5, and 2. What I'll do, I'll just have a look at this flyback here from the coil. That's the back EMF spike. And what I'll do, I'll just take this sheet or this copper off. I want to see if it actually moves. Yeah. That doesn't actually affect the flyback. I thought it might have dragged it out. But, oh my God, I took the copper sheet off, so I'll kill that. It's making just too much noise. Now, what I'll do, I've worked out a few things on this gadget. In the last video, I said that those Delta Sigma analog digital converters were well, 2 channels each. They're not, they're 8 channels each actually. So that probably corresponds to the amount of these 4053s here. It's probably converting whatever the 4053s are, spitting out. It's probably converting it, multiple channels per one. One possibly may be doing the mono mode. One may possibly be doing double D or cancel, and I'm pretty sure I found out that I'll just undo this, get on there. It's a good idea to give this a little bit of a tug every time you undo that nut. Otherwise you're just doing it in friction. Get round here. Remember I said don't touch the high voltage, but it's on the inside of the board, so pretty hard to get zapped. But I always handle the boards by the outside, like so. Now, that definitely is the cable goes to the transmit coil. This one, the one next to it, is the cable for receive. And this one here is floating all by itself with no ground. And I would say that this one is for the double D, the receive coil in a double D. And if you have both of these here, right, well then you can phase invert one and you can make it work in cancel mode. So that must be the mode switch on the double D coil. It probably has, this probably senses what coil is on and changes the mode. So that's probably that part of the circuit until a nice fellow out there says he's going to run a double D coil down for me to do the test. So if that comes, I'll do the test. Now, an interesting thing about this detector, the 7000 had a lot of power supply noise. This one doesn't. I went right over this with a fine-tooth comb, checking as much as I can get access to, and there is no power supply leakage noise. So this detector here, the 6000, is well, in my opinion, right, is actually a better design, uh, just the way it is designed. But still, it's very, very complex. Lots of parts on the board, or boards, I should say, not board. Yeah, so that's where we're up to with this gadget. A very, very interesting detector so far. Um, is there anything that can be done to it to improve the performance? I'm really thinking hard about this. The only thing I can think of, and I haven't even tested this, maybe putting in an internal magnetic shield just to cover the plastic module and these input cables from any earth field effect or anything like that. I don't even know if it requires it. I need to go out there in a really quiet area and whiz the coil around. If there is a earth field effect, people that use these all the time, if you're out in the middle of nowhere, you would know that's basically if you're swinging the detector through the Earth's magnetic field, because it is a stationary field, that if you get whoa, whoa sort of a sound, and the faster you do it, the more up in pitch it goes, that would indicate that there could be earth field pickup. It's like some detectors I've noticed actually do that when you tilt the coil. You tilt the coil like so, and you start picking up the earth field. Especially going up anything on an angle, hills or riverbanks and that, you'll get this warp. And I've actually found that on the 7000 as well. So if anyone finds this in their detecting or any strange, peculiar things that happen with any of these detectors, put it in the comments so it can be investigated. We can always, see if we can go out in the field and try and emulate the same problem. That's my thoughts on that. But yeah, that's basically where we are with this. It's yeah, I think Minelab in a way have killed the pig with this design. It is, like I say, people say it's noisy, but there's not a lot we can do about that, is there? You know, the magic here. And as far as I can tell too, I haven't actually nutted out where this grey wire goes, but I'm pretty sure this is the data from wherever it's dongled in the plug or in the coil. And because written down there, you can see it. I think you can see it. Tan, white, and screen. Well, it doesn't say what it is, but I'm pretty sure. You can see here, it's one of the wires has a little tiny inductor. That probably is to clean up any of the transmit waveform getting onto it, or stray noise. Depends how they toggle. I haven't even looked at see if this is a continuous data stream, or if it's just given data when you first turn it on, then it stops. I don't know. I should actually look at that. Yeah, there's a lot of things to look at. But yeah, it's got a inductor in here. I must make sure that you can see what I'm pointing at, because I can't see what I'm pointing at half the time. But yeah, a little tiny inductor in there, L403. There is D401, and I would say that is probably a protection diode there. And the rest of it is under the glue, which I dare not lift because it sticks too good, and it's on the components. So that's a bit of a problem, that glue stuff. No, I could probably experiment around, see what gets under it and gets it up, but yeah. This is a Lendy detector. I'm not going to do it to someone else's detector. This was just a see if we can improve it. That's what this one is here for. See if we can improve it. And I'm not sure that it can be. I'm really straining the brain to think of what can be improved. You know, if it's noisy, you possibly see. The thing is, you try and reduce noise, and you can increase noise. You could possibly, if it's too noisy. See, I've got this thing down as low as it goes, and it's still noisy. But there's a chance you're going to lose target signal. Well, you could, if you wanted to, is try putting small surface mount resistors on the receive lines and basically partially dampen them down, adding some resistors there. I'd started 1,000 ohms, and I'd work down and just see if there's any change. I'm not going to do that. It's theoretical, speculative, but you probably have to do the same on this one and that one. Now, I'm pretty sure that this one here is just dedicated transmit to the coil or the coil driver. You don't need to touch that, but possibly on these you could lower the gain, but you can't go put a pot in it or anything like that. It would cause a massive problem, and I don't even know what it would think about if you start lowering the gain at that point, because that might upset the analog to digital conversion. Depends how it's all set up and the voltage references to it. You might have to go and do a massive amount of changes, even changing one small thing. But yeah, this design, actually, I'll give it the thumbs up. It's fairly impressive in the way they've shut up the power supplies. There's basically nothing getting into anything on this design. It's a little bit different than the 7000, which can be made to be quieter. You just look at this sort of thing and you think to yourself, well, no, running this data line all the way back here, maybe the data, if it was anywhere else, would be starting to get into the receiver. That I don't know, but I can't measure any leakage here. And maybe it goes all the way back here because there's something, instead of being done on this board, maybe it's the handshake signals done in the headboard or in the bit you look at, the handle part. Maybe it's up there. I don't know. Like I say, I didn't design it. And so damn hard to go and try and have this operating and try and poke everything on the board with such small pitch that one slip and you can short two pins together with a oscilloscope probe, and your name will be mud. So that is why I don't do that sort of stuff on these boards. It's not mine. It was my own detector. I wouldn't care if I damaged it. I just repair it and carry on. But I'm not going to do that to someone else's detector. No way, no. Oh, and by the way, Ron, you said to David you're watching the videos. I have actually worked on your detector, by the way, just so you know. And the fault that you're saying that it was doing, I can't detect it. So I'm going to have to delve a little bit deeper on that, or I'm going to have to ring you and um, get some more information. So yeah, I think that you told David that I probably haven't even looked at your detector. No, I have. It's behind me in bits. So it's just that I was just head scratching about it, trying to think of why the detector would be making a clicking sound, but I can't reproduce it. You know, it could if you're running something like wireless system on it, which I don't have, or maybe it's a booster or something you've got on it that you know uh, pulses from the coil or proximity is getting into it, or something. I don't know. These are things I don't know. It's very hard to fix some things if it won't do it in front of your face. So yeah, I need more info on that. So I will give you a ring because I know you watch these videos. You told David. So yeah, so that's probably all I can say about this detector. Yeah, it's a little bit noisy, but that's the design. It's got some very interesting um, pulse pulses going to the coil, and it does look like that is uh, a good go. I was going to say attempt. No, it's a good go at covering various different sizes of gold by giving it a good hard sharp pulse for small stuff and turning the receiver on fairly quickly because the ground isn't lit up like a Christmas tree, and the big pulses there, which specifically more than likely are for larger size targets, and because it's on longer, it lights up the ground a little bit more. Yeah, so I don't know everything about this detector, but these things, these observations seem logical, and I just wonder on this sort of stuff. They go so far doing this. Why not put in some software that control the pulses, but keep the mathematics straight, and have it so you can set up a tiny coil and have a lot more of the small pulses, or general prospecting and use a lot of the medium-sized pulses and one or two of the larger ones, or go the hog and just put some big large pulses in there with big coils. You know, that might be for another detector down the line or something. But the way that these detectors work, they need various pulses at different lengths in different parts of the time period to make the ground balance work. You need to do the subtraction of decay rates and so forth. But anyway, that's probably enough on this. I don't know if I'll probably put this back together, and I'll go and do some field tests. I'll try some earth field observations, just see if there is anything to be had in that regard. But as a detector, uh, I would give it, I give it a good A plus out of the engineering part of things, and the operation of it being a little bit noisy. Like I say, it's designed to really ping on small gold, I'd say, and bring in the receive window a little bit closer, and you're going to get a little bit of ground noise. Anyway, leave it there. Catch us later.